In last week's video, there was a brief introduction to Habitat 67. The video covered the architect Moshe Safdie, who designed Habitat 67, the background of the Habitat 67 project, and various architectural and construction techniques used in Habitat 67, including modular construction, lifting system, and post-tensioning method. Among these, modular construction and lifting system were briefly introduced. In today's video, we will briefly explain what topics will be presented in the remaining weeks of the semester. Team 7's presentation video will be prepared to follow the typical construction process sequence to ensure consistency. The content you are currently viewing is the most common sequence of construction processes. So far, we have introduced from step 1 to step 3, which is conception, selection of the architect, and design, through week 2 and week 3 videos focusing on Habitat 67. In today's video, we will cover step 4, which is pre-construction, involving various preparation before actual construction begins. We will introduce site analysis, the architect's original thoughts and plans, foundation work, and construction stage documents. With this week's presentation, we will conclude the explanation of pre-con as mentioned earlier. And starting from next week, we will introduce the actual construction process and techniques used in that construction. Then let's explore the thoughts and various practical conditions that Moshe Safdie had before constructing Habitat 67. The origins of Habitat 67 date back to Moshe Safdie's master's thesis at McGill University. 23-year-old Safdie submitted his idea to 1967 Montreal World's Fair with the goal of piloting a new type of housing that would not contribute to urban sprawl. At world fairs, it's customary for innovative architecture designs to emerge, often diverging from conventional frameworks. Canada sought an architectural approach that could embody and reflect the practicalities of human living. Urban sprawl refers to the rapid and often unplanned expansion of urban areas beyond their original boundaries. It occurs due to continuous growth in urban infrastructure and construction of buildings, often disregarding traditional urban planning and development principles.
The first was zoning. We began dividing our cities up, separating them into their functions.
Residential in one part of the city, offices and employment in another part of the city, industry in another part of the city, all separated because the concept was you shouldn't mix different land uses in one place.
Urban sprawl is commonly associated with increased reliance on private transportation such as cars, easier accessibility to peri-urban areas, and insufficient public transportation options. Urban sprawl was propelled by the proliferation of automobiles. With the ability to traverse long distances quickly by car, cities became functionally fragmented. Moreover, adhering to the conventional notion of segregating land use within urban areas, development gravitated towards a model centered around automobile dependency. The scale and dimensions of the building first conceived by Moshe Safdie are different from the building actually completed in 1967. Safdie endeavored to integrate the benefits of single-family housing into apartment living. A key focus was on preserving both terrace space and privacy concurrently. To accomplish this, Safdie first introduced a modular design approach, aiming to ensure privacy and cost-effectiveness through a mixed arrangement for the terraces. Habitat 67's original design called for prefabricated apartment modules stacked in 20 stories on a hill, with each unit envisaged having a garden. The structures sit above the public space below, with streets arranged every 4 floors. Safdie envisaged that every home would have its own rooftop terrace, with gardens open to the sky rather than balconies, creating a sense of suburban living in the city. At the time, it cost $45 million to build a community of 1,200 homes. which today would probably cost $450 million. However, due to practical limitation and financial difficulties, the plan, realized with a budget of $15 million, was reduced to 158 households. Now, let's analyze the actual location where Habitat 67 was built. Two islands were created for the exhibition, and the two islands are connected to the mainland by a bridge. It is very easy to get to the surrounding islands and downtown by connecting to the Big Lang Bridge in front of you. Just above it is a park which is surrounded by a harbor, logistic warehouse, sports center and hotel. On the left is bustling downtown area, and on the right is entertainment facilities and parks to enjoy nightlife. Located surrounded by a river, the narrow and long side form has no obstacle that can bend or block the wind, so the ventilation is very pleasant, and the elevation or shape is not blocked, and the wind path between the unit is well established. In addition, such a structure makes it easy for sunlight to diffuse, so sunlight can be evenly distributed throughout the dwelling. Downtown Montreal and at the bottom of Habitat 67 are a cluster of industry, industrial and business estates. It is also the mainstay of the city's economy, and its location is close to the city center and the river, making it suitable for transportation supply. Now, let's delve into the groundwork that must be carried out before the actual construction of the building itself, specifically focusing on the foundation work or groundworks. As the construction year of Habitat 67, as indicated by the building's name, is 1967. There may not be abundant data available on excavation work, but there is information regarding the pile foundation. We will center our explanation around this aspect. Habitat 67 utilized a pile foundation, a type of deep foundation system commonly used in areas with unstable soil conditions or when building on soft ground. In the case of Habitat 67, where the construction occurred near water bodies, pile foundations were likely chosen to provide sufficient support and stability for the structure. Pile foundations consist of long, slender columns, known as piles, that are driven or drilled into the ground until they reach a stable soil layer or bedrock. These piles transfer the structural load of the building to the deeper, more stable layers of soil or rock beneath the surface, effectively distributing the weight and preventing settlement or movement of the structure. After the pile foundation work, Habitat 67 also utilized a mat foundation. The characteristic of mat foundation is that it can uniformly distribute the load of a building. A mat foundation uses a large concrete plate that covers the entire floor surface of a building and widely distributes the load of the building. Therefore, the load of the building is evenly distributed on the ground, thereby minimizing the deformation of the ground and increasing safety. The exact construction details and specification of the pile foundation for Habitat 67 would depend on factors such as soil conditions, building design, and local building codes. However, pile foundations are known for their durability and ability to withstand various environmental conditions, making them a suitable choice for supporting large and complex structures like Habitat 67. The picture materials we are showing you now are the actual drawings designed and created by architect Moshe Safdie himself for the construction of Habitat 67. These include diagrams of precast concrete components to be used in Habitat 67, as well as sections and floor plans. The following are actual drawing photographs taken during the design and construction process. Various design drawings for the construction of Habitat 67 were found, such as reinforcement in boxes, staircases, plans of elevator core, elevated walkway, construction pieces, and side sections. Although there are no 3D models or computer program drawing due to the era, Moshe Safdie's passion embroidered on paper drawings seem to be felt well. So far, We have based today's presentation on the construction process involved in creating actual buildings. Before actual construction begins, we cover the pre-con stage, introducing topics such as site analysis, the architect's original thoughts and plans, foundation work, and construction stage documents. Starting from the next video, we will focus on introducing various construction techniques used in Habitat 67 in detail. As mentioned earlier, following the sequence of construction when Habitat 67 was built, we will first conduct detailed research and organization on modular construction. We will introduce the modular construction method used during the construction of Habitat 67 and compare it with modern modular construction, highlighting any differences. Similarly, we will discuss the lifting system and post-tensioning method, presenting the methods and technologies used during the construction of Habitat 67 and explaining how they have evolved to the present day. Thank you very much for listening to Team 7's presentation so far.